Now, Jennifer and Yash will be talking about how Alectio migrated from Airflow to Flyte to build the first MLOps pipeline for data-centric AI. Jennifer is the founder and CEO of Alectio, a company created to automate the cleaning and optimization of trained datasets. And Yash is an MLOps/DevOps engineer at Alectio, and he has been a core contributor to the Flyte migration. Jennifer and Yash, the floor is yours.
Thank you, Samita. Very good introduction. I appreciate the time you guys are allocating to us, right? I mean, so look, I've never seen such a fantastic transition, like going from talking about like data labeling to what we're going to discuss now, because like we're doing at scale, like basically basically empowering users to annotate their data more efficiently. So we're going to talk about active learning and whatnot. But so I will start by saying that, we migrated to Flyte because like other solutions, especially Airflow, was not giving us the horsepower and the capabilities to basically like perform this kind of operations where you have like a human in the loop element, where you have like a repetitive tasks that are supposed to do the same thing over and over again, right? I mean, so without further ado, right? I mean, so basically like I'm going to share my screen. I have a couple of slides I can share. So the goal is to, let me see my screen. Let me switch to slide mode, right? I mean, so you should see my screen on, or my slide on the full on your screen, right? So as Samita said, right, I mean, so we are a relatively small company. We've been around for a couple of years now, right? And so basically like we are pioneering a new space, which I ended up calling DataPrepOps, which is sort of like an adjacent field to MLOps, which is basically like you can see this as being like a MLOps for a data-centric AI approach to training a machine learning model, or you can see this as incrementally improving your data set as opposed to training your model, right? And so what you're going to see today has a lot of similarity with machine learning, traditional pipelines. Of course, there's a lot of like things that can be reused and learnings we can use from building a traditional machine learning platform, but there are also lots of challenges that we felt like typically Airflow was not helping us solve, right? And so basically, like, before we jump into like architecture conversations and like issues with like building the system or whatnot, I'd like to explain a little bit more like basically where you need to see DataPrepOps on the market, right? So basically the way I explain the market is like MLOps has been like around, like basically became a popular field like about like 8 years ago. And so historically what happened is like MLOps was born out of necessity, because when machine learning became popular among companies and companies started hiring like data scientists everywhere, usually you would have people who were excellent mathematicians who could build models, but they had no idea how to deploy, right? And so the original mission of MLOps was making it easier to first deploy pipeline, connect to production pipelines, right? And because what was happening, like basically when I started my career in machine learning, is that I could build an awesome model, but I had no idea how to push this to production, connect to data pipelines or whatnot, right? And then the field matured, and little by little, we started seeing other companies that would support us in other aspects of machine learning or model building, right? I mean, such as automatically tuning a model, automatically choosing the architecture of a deep learning network or whatnot, right? I mean, I'm not going to say that MLOps is completely overcrowded, but it's getting there. And, like you're probably going to see some consolidation, because like as a user, basically, I want to have everything in one place where building the model becomes super easy for me, right? Of course, at that stage, we know that the problem is the preparation of the data, right? And so we are kept, or users are kept, I would say even investors are kept under the illusion that data ops is a closed field, right? Because like you have Snowflake, you have Databricks, you have like a beautiful data lake, data mesh, like basically like technologies out there. But if you're actually messing with an actual machine learning model, of course, you know that the state in which your data set is when you collect it, no matter how large it is never good enough to be injected into a model, right? I mean, so think of an object detection model, a segmentation model, or whatnot, you can have as many pictures as you want. Those pictures can be like a low or high quality, but even if they are high quality, you still need to get it annotated, right? And so what do you have right now on the market? You put that in some storage somewhere, you send a message to Scale AI to label box, you wait for them to get back to you and tell you that your data has been annotated, usually to discover that the whole thing is a disaster. It's not been done properly, right? And so basically, like, really shows like the necessity today that, you know, like, you still have like a human involved in that transaction with those labeling companies, right? I mean, so those labeling companies definitely fall within the DataPrepOps market, right? I mean, are basically like a category of companies, but the goal of what we're providing is the end-to-end. Why? Because we have continuous pipelines for building and deploying and tuning, maintaining, like monitoring a machine learning model. But the moment that you need to retrain and you need to re-inject data into the pipeline, you have to hit pause and you have to go back like to basically like figuring out like who's annotating your data, what data needs to be annotated, whether you can trust the annotations. And that's just talking about annotation, like what we didn't discuss earlier is like you might have to cleanse the data, automate the, you know, like augment the data or whatnot, right? So that's basically like what we're trying to build when we talk about like a MLOps platform for data preparation. It's really like an end-to-end workflow that covers the point where you can feed raw data into it, and basically you get like data that's machine learning ready to be fed into your machine learning model, right? So the other, like basically like we talked, or you guys talked about active learning a little bit earlier, right? So basically like we're very heavy on active learning because my position is the reason why preparing data is so complicated is mostly coming from the volume, right? And so if you could work with data sets that have a size of like 5,000 records instead of like 5 million records, right? I mean, technically it would be easier to validate, make sure that the annotations are right, decide whether a specific record is worthy or not, right? But the pain points mostly come from the volume, and so do the cost and the training time and whatnot, right? So there is a huge value proposition in curating the data, but that goes like a little bit counter trend with what most people are used to, right? Because we are used to working with large data sets because we believe more data means more information, which is the case. But what everybody needs to understand is that information is typically not well located, or basically it's not well distributed in the data set, right? I mean, so that means that even if you have 10 million pictures, there is no way every single one of those pictures carry the same level of information. In fact, many of them are going to be containing similar information or whatnot, right? I mean, so this is actually good news because it means that you can get the same amount of information by training on a subset of the data. The question is like, what subset of the data? And so one of the answers is basically like a active learning and a more sophisticated version of active learning, which is basically what we do, right? I mean, so I hope this sets the context. So let's move on to that, right? I mean, so I started talking about data-centric AI a little bit. So basically like not super necessary to understand, you know, like the pipeline or whatnot, but I think contextually speaking, it's going to help, right? So the way the community is typically building machine learning models is to iterate on the model, right? I mean, so basically, like normally, like if you're an entry-level data scientist, you don't know much, like the way you've been taught to do machine learning in school is basically like you collect your data, you prepare your data set, and then you start building a model, and then you iterate on that model. You go through phases of like training, validation, until you're reasonably happy with the results, right? During that validation process, you're going to tune your hyperparameters. You might change your mind about which is the best like architecture type of model you're going to use. And then eventually, when you reach the point where you're satisfied, then you move on to the test phase and you're ready to go with your model, right? So we're used to the iterativeness of machine learning, but the iteration typically was never done on the data set. It was always done on the model side of things, right? So this is what a model-centric AI approach looks like and is like, and it's like the vanilla machine learning kind of approach, right? Or supervised machine learning approach. what data-centric AI does, right? And so it's kind of a buzz term, like for several companies and like institutions have been using the term quite profusely. And I still think like people don't understand quite what it means, right? So basically, instead of doing this, you trust that your model is in a decent shape, right? I mean, which you could do if you already used that model before. You're just trying to retrain, like, for example, in the case of like a ML observability or whatnot, right? I mean, so in this case, you sort of do the opposite. You freeze the model. You want to iterate on the data, right? And so when we say like you want to iterate on the data, like you have many things you can do to iterate on the data, right? I mean, so you can actually curate the data, so select which records are going to be used. You can annotate the data, obviously, fix the annotation, change your minds on how the annotations are made, choose to augment parts of the data, the entire data set. In fact, data-centric AI would also include like the case where you remove records, right? I mean, if you realize like some of the data is corrupted by means of like analyzing the reaction of the model, there is no reason why you wouldn't also iterate by taking stuff out instead of adding it afterwards, right? I mean, so technically, like really what makes like data-centric AI, usually people assume is necessarily like a human-centric approach. It necessarily means like human in the loop. It necessarily means like selection of the data. That's actually not the case. It's just basically like now you're treating your data set as a flexible object that can be manipulated, that can be modified, that can be improved, right? And that can be tuned, right? I mean, basically like during the process. So it's interesting because like we all talk about tuning. Usually we talk about tuning the parameters of a model, but like now we need to start talking about tuning the data set itself, right? And so this is what data-centric AI is, right? And so of course, your traditional machine learning pipeline does not support that, right? Because it requires more granularity. You have to act on a record level. So basically you're gonna face like tons of scalability issue. You do need to include the possibility for the intervention of a human user and whatnot, right? I mean, so just to explain quickly for those who are not too familiar with active learning, what active learning actually does, right? I mean, so active learning is just one piece of the data-centric AI puzzle, right? And typically the idea is like you have a very large data set and the goal is to basically like either prioritize or select the data that's the most impactful to your model, right? And so something that, is quite interesting is basically like it's sort of like doing data preparation with the output of the model or the knowledge of how the model has understood things so far, right? I mean, and so that's a complete shift in paradigm with traditional labeling companies, because traditional labeling companies think of data preparation and data labeling as an independent step, right? I mean, so basically like they annotate your data without having an explicit knowledge of which models you're going to use, right? I mean, basically which difficulties this model can use or whatnot, right? I mean, so what I love about active learning is definitely that, you're sort of like inputting the feedback of the model itself as you curate your data. So it's not the full answer, but it brings us like much further, right? I mean, so one simplistic way of seeing how active learning works is like it's growing a good data set from a raw data set, right? I mean, so I like the idea of growth because like I'm going to explain later, but so you iterate many times on the data that you have on your original like pool of training records, right? And you basically grow this into like by selecting the data that's the most useful, right? So that's basically like the workflow that active learning uses, right? I mean, so let me explain a little bit more, right? I mean, so if you want to have like a vanilla example, let's assume now that I have 100,000 pictures for, let's say, like a image classification, binary classification problem or whatnot, right? I mean, so basically, and I don't have enough money to annotate my entire data set, or I don't have the experts to annotate my data set. So for the case of cats and dogs, that wouldn't necessarily be a problem. Now, if you're annotating like X-rays of like a specific body part that requires like a surgeon or a doctor to annotate the data, then getting someone to annotate, or a group of people who can annotate 100,000 records can be a problem, right? So your goal here is, why should I annotate everything? Why should I use everything? Why don't I just like figure out like the data that contains the most relevant information that's truly going to help my model learn, right? So the way you do this is actually incredibly simple, but it's incredibly difficult to implement, right? I mean, so the way that you start the process is like, out of those 100,000 pictures, you select a small sample, let's say 1,000. You're going to annotate this data, and then you're going to train your model with it, assuming you already have your model, right? Now, you're not crazy. You know that when you train a model with 1,000 records, especially a computer vision model, chances are it's not going to be that great. It's probably going to suck, right? So you have no hopes of pushing this to production. This is just a temporary state. But the good news is like your model, you have a starting point, right? I mean, so you have a model in a certain state. And then the name of the game here is to try to analyze the state of the model to try to assume or predict what it is that you should select next, right? I mean, so at that point, you have 100,000 pictures minus the 1,000 you just used. So 99,000 pictures which you haven't used yet, which are not annotated yet, right? So basically, like now, in order to try to guess what to use next, typically what people do is like run that model and infer on the rest of the data, so the 99,000, and try to look at the output to make a good decision into like what helps and what doesn't help, right? I mean, so normally you would be tempted to say, I'm going to select the data which was mispredicted because that's a signal that the model doesn't know about that data yet, right? You cannot do that because you don't have the annotations, right? So what you do instead is rely on metadata such as confidence level, right? I mean, so a very popular approach for this active learning selection is basically like, and so you call that the querying strategy, is to say, now I'm going to look for the pictures that led to the predictions with the least confidence score, right? I mean, and so this is called the least confidence approach for active learning. Then you take your 1,000 records, you put that back in the pipeline. So in my little like illustration here, you go from using the information of the infer step back and you feed that back into selection for the next step, right? I mean, so you use the output of the inference process to basically like make a decision what to select, and then you keep labeling what you added, you retrain, right? So that comes with a bunch of problems, including you need to version the model, you need to repeat, you need to reuse the same processes many times, right? You need to be able to immediately reuse the model you just trained, right? And all sorts of things like associated to like typically not what you would do to or with a machine learning model, right? The other part of the challenge here, which we also solved over the years, is basically like this happens in a continuous fashion. So you also need to continuously label, right? I mean, so people usually think of labeling as like an asynchronous step. In our case, like we're really trying to build something where it happens on the fly, and it can happen on the fly. It should happen on the fly because now you're talking about much smaller volumes, right? And so going back to my 100,000 pictures, if you're lucky, maybe only 10,000 pictures contain the right information, which would mean like by picking 1,000, you would stop after 10 iterations, right? And each batch is going to be 1,000 records instead of being 100,000 records, which basically like makes it much easier for a smaller group of people or even your own team to do that themselves. Or if you use a third party, basically they should be able to get you back the results very quickly, right? And so this is basically like a kind of a big picture on DataPrepOps, right? I mean, so anyway, so this is basically like what we've built, right? I mean, so basically like, so it's by no means like the, the perfect solution. There are lots of other pieces that need to happen, but basically just to give you a sense of like how the system is built and the different pieces, how they need to communicate to each other, right? I mean, so basically you go back to that workflow before, right? The way that we've built the process is basically, for one, we don't host the model, we don't host the data, we just coordinate. So it's almost like a federated learning process with just like one instance where the data and the model lives with the customer for the sake of providing them privacy, right? I mean, so basically like they don't have to share the data if they don't want to, right? And for a second reason, basically because we don't want to host the data, like the crazy large data sets of our customers. Right? So that SDK process over here, right? I mean, basically like it's built in a way where we trigger the training process and we can basically like retrieve. So that's part of the pipeline. Like we can record what happens during the training process, including like looking at the loss function, the activation function, so whatever clues we might be using, right? And so that information gets piped back into our system, right? And so this is where it becomes important to have like a solid, scalable workflow that can basically like retrieve like a relatively large like sets of data that, you know, like basically relate to like what you could call that the log files of the training process, right? So the piece in the middle here is our backend, right? And so basically like in here you have like several like microservices, including like an active learning microservice. So we don't call that active learning, but it follows like an active learning workflow because you're gonna do this repetitively. But the logic on how data gets selected in our case is much more complicated than just relying on the least confidence level, right? I mean, so in fact, we look at all dimensions of the training process so that what gets selected is actually what matters, right? I mean, it is actually like what is supposed to be the optimal subset of data that's the most likely to impact the training process, right? I mean, so you can see this as being a machine learning driven or a smart version of active learning where we don't use arbitrary rules, right? Then when the data gets selected, basically, of course, you need to annotate as per my workflow earlier, right? I mean, so you select and then you label, right? And again, because this is literally like curating and preparing your data on the fly as you train, you also need to be able to annotate the data on the fly as you train, right? So the rest of the pipeline for us is basically like we can route the data that was selected from the user or the customer to the labeling company which we selected, right? And so no need to go in the details. We have recommendation systems to like figure out who is available among the labeling companies we work with, how, you know, like how many people can take care of this and whatnot, right? But so basically like so the data goes there. So we also need pipelines that can securely like share like the indices that were selected, the data, like the expectations from the user and whatnot, right? Then it gets annotated. So in fact, we have options to do that either with a human annotator or with an auto-labeling model, right? And then that comes back on the platform, hopefully like within like less than an hour because the batches are smaller, right? And then it goes on the UI of our platform and people can play with it, right? I mean, so they can say like, wait a second, I asked you guys to annotate trucks as cars, but you annotated pickup trucks as trucks or whatnot, right? I mean, so the user has the option to like tune the data that comes back or whatnot. And so depending on whether they're happy with it, like if now, for example, they say like 20% of my data is misannotated, they can send it back. So basically like we have this pretty interesting workflow where we deploy like an auditing system where we look for anomalies. We help like assist the user in finding problems. If there are problems, they can re-annotate. If there are no problems, they can move forward. When they move forward, basically like everything needs to be versioned. That's obviously a big problem because if you have like an original data set of like hundreds of thousands of records, basically you need to keep track like which ones were the right version for the annotations, right? We have a secondary workflow that's also interesting where, you know, like part of the, you know, like if the annotator made too many mistakes or the user made too many corrections, basically we can mark them as an inappropriate like vendor for that specific use case or whatnot. And so boom, everything gets done, goes back into the system, we send a signal and basically like the training process retrains, right? I mean, so basically like, so we're talking about a workflow which is like very heavy in terms of like repeating the same operations over and over again with different versions of the model, with different subsets of the data where you need a ton of versioning and you need a lot of stability. And so God forbid, but the biggest disaster that can happen is like you run 7 loops and then your process freezes for loop 8 and you have to start everything over, right? And that used to happen a lot with Airflow, right? So basically, like, so historically going back to like the times when I started the company, so Airflow was the natural kind of you know, like option for data engineering, data orchestration or whatnot, right? And we constantly used to run into problems where, you know, like a process doesn't scale or like there is an error which cannot be tracked or repeated or debugged easily or whatnot, right? I mean, it's all coming back from the fact that the intensity of the process, because now you're looking at multi-dimensional aspects of the model of the data or whatnot, like basically like Airflow was just not doing the job anymore, right? So we wrote a little blog post like a couple of weeks ago on like all of the problems that we faced, right? I mean, so I don't necessarily want to go in every single detail, right? But so we had problems with versioning capabilities. The tasks were not reusable. The problem we have in our case is like this selection process, this querying strategy, like that powers the active learning workflow, depends on the model. So you need the same workflow, but different variations for different use cases, different customers. So basically like Airflow was not enabling us to do that without like explicitly copy pasting the tasks, right? I mean, so that was a big problem, right? For whatever reason, like Airflow doesn't seem to play nicely with like the communication of data from one block to another. And so basically like for a data-centric AI approach, this is an absolute disaster. There are other like secondary kind of problems where it wasn't necessarily playing nice with like our microservices, the other parts of the system or whatnot, the plugins that we need to use, because in our case, like every block is not just a passing gate, it's basically like an operation that requires like either to wait on another process to be complete or whatnot, right? And we had a huge problem with horizontal scalability. So basically like we were sort of doing okay with like large volumes of data to curate, right, and to prepare, but we were doing terribly when you had more than like 3, 4, 5 customers running the process at once, right? And so eventually we reached the point where the engineers were like, so the customers were angry first, and then the engineers are like, we cannot keep doing this because like it's impossible to debug. Customers report like specific errors that they try, but basically when we try to reproduce the error, it just doesn't happen the same way on our side or whatnot, right? I mean, so a decision was made to move on to, you know, like basically like other, like explore other potential like workflows or whatnot, right? And so we explored like a Prefect, we explored like a Kubeflow and whatnot, and eventually we felt like the best option for us was Flyte, right? I mean, so you want the details. So basically, Yash was on the call as well, is basically like one of the people who led the migration. So I'm sure he would be happy to discuss longer into like what really made us feel that Flyte was not only just better than Airflow, but it was better than any other option on the market at that time. Right? So anyway, so we're fully migrated on Flyte nowadays, right? And so basically your first like DataPrepOps, like end-to-end like workflow out there is powered by Flyte. So if that matters, right, and hopefully it matters. And so basically like, so of course it's a small part of our system, because our system is like really a collection of like, you know, like different like labeling validation processes, selection processes. But so the backbone is really Flyte for us, right? I mean, because it's really something that helps us scale and reach the level we're at today, right? I mean, so yeah, I mean, basically like just a couple of examples of our architecture. The full orchestration is powered by Flyte, and never had a problem since with like integration of other, you know, like basically like processes, other technologies or whatnot. Like we have like much fewer complaints than ever before, right? I mean, so yeah, so if somebody is trying to do something in that space, I strongly like suggest that, you know, like you don't even try to get started with old legacy like orchestration systems that are on the market. All right, that's it, folks. So I hope this was interesting. Like we're happy to take any questions if anything comes to mind.
Thanks, Jennifer. Just an FYI, I now have a full understanding of active learning. Thank you so much for explaining in detail.
I appreciate it.
And Alectio's mission is commendable. Yeah, anybody? Questions?
All right, okay. Guys, if you don't have questions,
has a question.
Yeah, I was going to say, if you don't have questions, I hope that it's because it's super clear and not because it was boring. But
I always have questions, so I let people ask. Otherwise, I'm always asking questions. But I think it more than a question. I think what I wanted to say, like, echo what Sumita said. I did not know active learning as crystal clear as now I do. So thank you. I think for a community, this part of the community think is also that the community kind of learns and grows from each other's experiences. So thank you for sharing that. We will do our best to spread your message to the community and beyond, because I think it's needed. As I have in my prior life, I have faced the problem with like, how do you label this data? And this is a lot of data. How do I label it, right? So I completely understand. What was amazing to understand is that it kind of laid the groundwork of why you needed something like Flyte. We would love to dive more into details. I know some of it could be proprietary, but like, how did you actually end up doing it? What the system looks like? But I think at least I get a basic amount of idea. But one question that I would like to know is, how did you hear about Flyte? And
look, I read a lot, we read a lot. It was just like one thing I knew at some point is like, I'm done with Airflow, right? So basically like, so interestingly, like, the first option was like, like Kubeflow became popular like basically a few years ago. So basically like that was like one of the main like alternatives you had, like especially if you were working with Kubernetes. But so Yash, if you're still on the call, right? I mean, you guys talked a lot, and basically, like, I think there is quite a lot of prototyping done, and eventually, like, one day it was clear that it was Flyte and nothing else, right? I mean, so basically, like, what technical like decisions were exactly made? Like, it's more like in fact, from my point of view, it looks a lot like the quality of like basically was easier to use for us. Like there was more support from your community for basically like solving issues or whatnot, right? And basically like so generally speaking, like stability, scalability or whatnot, right? And so basically we faced other problems like when using workflow where we felt like even if we would migrate, that there are a lot of problems that we were facing with Airflow we are still going to face. But Yash, if you're still here, you want to add something, feel free to. But like, yeah. I mean, those like basically my engineering team fell in love with Flyte at some point, and then basically like, when I saw how quickly we were able to migrate and basically like cover all of our problems, that was a no-brainer. Right?
Yes, you were saying something.
No, Miss. Miss, we are going to. Sorry, Miss. So, okay, yeah, sorry for that.
Okay. No, so I think you answered the second question also, because oftentimes when people come to the community, they are like, we are evaluating, because today this is the world where we have to evaluate a few solutions. But I think sometimes some really large companies who've been me have had questions about how long would it take to migrate, right? And that's like the concern usually, because they are so entrenched in a legacy ecosystem at times. So hearing this and that you were quick, and that's why I wanted to know, like, when did you learn and how much time did it take?
I'm going to say, right, I mean, so you see the complexity of the workflow, right? I mean, it's not just like a passing gate or whatnot, like you have lots of like moving blocks or whatnot, right? I mean, so I'm going to say like the main migration, of course, there are always like, like tricky details for like, like different types of data or whatnot, but like the whole migration was done in less than a month, right? I mean, basically like the actual creation like of the workflow, right? I mean, so you guys were amazing for, like basically like so like we're using GCP basically like for most of the storage and the hosting, right? And so that was like apparently like that was not like the natural like decision or like the most common, like obviously people tend to use more AWS or whatnot. So on top of the technology itself, like we felt really supported by people providing answers relatively quickly, right? And basically like we had a couple of like like basically like Yash, correct me if I'm wrong, but basically like basically like garbage collection issues that were not like like supported for GCP or whatnot, and same thing, like you guys fixed that like in just a couple of days. So wasn't an issue at all.
Thank you, Jennifer. That's it from my end. Anybody else to ask?
I have just a quick question about how you think about data as code. The whole idea of, machine learning and, whatever software 2.0, where the ML model is simply a meta program that optimizes the mapping between data.
Yeah.
So if data is the first class citizen here, like what are some constructs and how has Flyte helped you kind of reason about and handle the complexity of just like human labels, right?
Before going into data as code, right? I mean, basically, look, I think all we're trying to do now, and so ChatGPT is sort of the proof of this, is like empower the regular Joe to basically use AI on their daily basis, right? And so, of course, we want this to expand into not just using a standard application, because of course ChatGPT is like a chatbot, so basically it's kind of a general purpose, but basically if a person in any company who's not a data scientist wants to build a model for whatever it is that they are doing, they should be able to do that. That's the purpose of low code, no code, wherever, whatever first step you take in that direction, right? And so that was exactly it's a big part of the mission of what we do, because you look at what you have today, you have Data Robot, for example, that pretty much automates the choice of the right model, the choice of the features. You have lots of technologies and even open source software that help you tune the model or whatnot. But the data is the bottleneck, and so we all spend ridiculous amount of times as data scientists, basically figuring out what should I use, what should I not, right? In fact, there is this danger that basically if you curate the data manually, you induce biases into basically we've seen that problem recently with ChatGPT, that any strong political opinion is being cleared from the at the content moderation step, at the labeling step or whatnot, and this is you can see that as a good thing because you're protecting the population from strong political antagonization or whatnot, right? But you can also see this as being a bias, right? And so of course it's a bias. So the fact that what we're building, it's really taking the response of the model to empower. It's almost like empowering the model to pick its own data for its own sake, right? I mean, so it's it's giving the opportunity to basically take the same step. This is why I started my presentation like this, right? I mean, where MLOps really brought us to the point where you don't need somebody with a PhD anymore to build and deploy a machine learning model, right? You don't need a team of 20 DevOps engineers, right? That was the goal, right? So it's empowering the single person, even though at this stage you probably still want to have an expert, right? But so the same move and the same transition needs to happen for data, because at this stage, it's sort of ridiculous that basically you have pipelines and sophisticated pipelines and automation for tuning, creating, and deploying a model, but you don't have anything like this for preparing the data, right? I mean, so this is really Alectio is also trying to go towards a low-code data, and so eventually by plugging both, you're gonna end up in a situation where it's an end-to-end, basically low-code, no-code solution.
Awesome, thank you.
Hey, Jennifer, this is Martin. I'm with you, and then how are you today?
I'm good.
Hey, Martin, sorry to step in, but I think Siddharth had a question before you.
Oh, I'm sorry.
Yeah, let Siddharth go, and then maybe.
Yeah, that's all right. Oh, thanks. I think my question is not directly related to the platform as a whole, but rather one of the components which is inside. So that's why I'm not really sure if Jennifer can clarify this. Maybe it's something proprietary, but I just wanted to take one small example of object detection and data preparation for object detection, especially in the scenario of, let's say, retraining the model.
Yeah.
So I just want to think of I just want to put this question out, and I mean, I would really love to know how you handle this. So let's say, for example, there was an image which was trained on the model is trained on that image, and it inferences on another image. Let's say it detects a object which is a cup or something of that sort, some sort of object. Once the detection is done and it comes back to the user in your case, and then maybe he finds out that I think the model only saw the partial, maybe a half of the cup. It didn't see the entire cup. Right. So now the bounding box of the cup, it has to be retrained or sort of sent back.
Right.
And this is your feedback. right? And maybe that's one situation. The second situation is it saw a red cup when it's actually an orange cup, right? So what I'm trying to get to is there may be many factors where the user might have some edge cases. Maybe his bounding box is not complete. Maybe the color is different, and so on.
Right.
So I was wondering, not as a maybe as a, it's a two-part question. As a platform, how do you address this, and how do you internally keep track of all these feedbacks that the user is giving?
So let me. So it's a multi-part answer, and obviously, and you're right, it's an incredibly complicated problem. But so basically, like, so our current workflow, the purpose is basically like a. You mentioned basically like the performance of the model on the test set, right? I mean, so basically like, so
right.
That like we are to some extent, but basically we're not directly like the purpose of like the end-to-end workflow. The automated part is concerned with the selection of training data and the annotation of training data, right? I mean, so to some extent that your question relates to that as well, where basically like, so what's pretty cool with active learning is like active learning basically like measures where the model is weak, and typically the model tends to be weaker in places where you have like a lower density of information. So let's say I do cats and dogs. If out of raw chance I selected a lot of dogs, my model is going to be weaker on cats.
Weaker on cats,
It's gonna know it, but you don't even need to know it's a cat. You know that there is a fraction of the data where the confidence level, the entropy, basically like all sorts of signals coming out of the model are going to be lower. So it automatically rebalances, right? Regardless of that, so you select that data, you send that to your labeling process, which can be automated or a labeling company. Then that comes back on the platform. On the platform, we offer tons of options for people to evaluate manually, to use like anomaly detection frameworks or whatnot, right? But at that point, the data hasn't been used yet, right? I mean, so basically there is an iterative process where we practically don't allow the user to proceed with the next batch until they validated some quality, right? I mean, over time, we're adding more and more. So if that problem happened with the cup, where the cup has been annotated, but it's not fully annotated, basically, like I'll give you an example of something we do, right? I mean, so we check like the distribution of like the object size, right? I mean, so basically, let's say most of your cups have a height or an aspect ratio of like this much by this much. If your cup was not fully annotated, right? I mean, basically, like it would have a different aspect. The ratio would be different. That does not mean it's wrong, but we're warning the user, please cross-check. And then they can decide to fix it, or they can decide to send it back to either the same labeling company or another labeling company, right? Then
that's great.
In a separately, what we do is like you have reports where we show the distribution of everything. So again, your cup example, you would see all of the annotated cups, and you would see like where they fall on average on the images or whatnot, right? And so basically like it's allowing you like a way to like identify like the harder objects or the ones that are explanation or whatnot, right? I mean, so what is the potential next step for us is basically like you could also like use the annotations and the predictions coming out of the test set, right? I mean, and basically like also feed this in the same reports, and then you would see like, wait a second, how come all of the cups in the process or all the cups in the data sets are always located on the bottom left of the images? Might be a feature, might be a bug, right? But at least you bring up the attention to this.
Perfect. Yeah. Thanks a lot.
Martin?
Yeah, so I just have a very simple question about synthetic data, Jennifer. Obviously, we have been talking about synthetic data for quite a while, and so I was just wondering how this affects you. Have you actually worked with? I mean, I saw in your chart earlier you have like synthetic data. How does it affect, you know, the overall outcome using synthetic data versus not? And I assume that's dependent on, you know, what kind of cognitive service you do, if you do speech vision or whatever else. Yeah,
your first or second thought. Yeah, I think I got your answer, your question. So look, so basically, like, so the next generation of what we do is like, so the regular active learning is basically like you have a lot of data, but you want to select the best subset, right? But you don't make up additional data, right? I mean, so basically this assumes that somewhere in your existing like collected data set, you already have the answer. It's just that there is a lot of noise on top of this, right? Now, the one thing no one ever thought about, which is kind of like the feature of active learning within Alectio, is basically like if you trust your active learning process, you have like a really like scientific way of doing active learning. Not only you prioritize the most useful data, but you can start looking at correlations, right? I mean, so basically like one of the things that we're capable of doing is to say like, look, when like the active learning process called a higher density of trucks first, right? I mean, so for example, I've seen that situation where all the trucks we had in the data set were called first and prioritized, and then you run out of trucks, and then the learning curve and the accuracy for trucks stopped going up, which makes sense, right? But so sometimes you have cross effects where you run out of cats and then the accuracy for dogs stop going up, which is basically what's going to happen when you are at the, you know, basically if the boundary between cats and dogs is sort of like unclear, right? So you can use that sort of feedback to say like, okay, I need more dogs, right? And, you know, I need more trucks or whatnot, right? And so that leads you to potentially like having like, and so we have that workflow, but it's not deployed in prod yet, right? Basically, it's like based on that kind of criteria, you can augment and you can synthesize data that you have identified for being useful, but you don't have enough of in your data set, right? And so it opens the door to a next generation, basically like of data problems where you start with natural data, but basically like you use synthetic data as a complement, right? And so usually like today, when you look at the ecosystem, you have people using synthetic data, you have people using natural data, and usually they don't talk to each other. They don't see a way to, you know, like work together. And I think this is the path.
So I think I take it that this way today you look at it as more a method to treat and balance, and then with oversampling, undersampling, and so on, according to that. And then down the future, I think it's going to replace. I feel like, you know, in certain areas we see how synthetic data is already replacing.
Replace, it's like really like, you know, like basically like making it play nicely together, right? I mean, because basically like, so one of the thing nobody thought about is like, people use active learning in a way to like prioritize their data, but they don't think that the process itself provides you feedback on what the model needs, how the model learns. In fact, you can even use that as an explainability framework, right? And so it's a completely new area where people don't you like, you think of explainability, you think about like which features were predictive of a specific outcome or whatnot. But in our case, it's basically like you know, like a real opportunity where you can say like, this 5% of the data was really useful. Why was it useful? What was special about this, right? I mean, basically, is there a higher density of information? In fact, we found lots of things where models start to struggle when the density of information is too high, which is an interesting takeaway because like technically what I'm saying is like the distribution of the data, the training data does not need to match the distribution of the test set, which is like you know, like light years from what we are used to thinking, right? And so basically we have had situations where you can train with a data set where the maximum number of cars per image is like 3, 4, 5, but the model still does an excellent job at predicting like images in a situation where you have 20 cars in the image, right? And
yes, you have a lot more questions. I'm going to hold off. I can ask them line.
We have gone beyond the allotted time for the meeting, but I have a quick question. Niels mentioned earlier that active learning usually requires some kind of manual intervention during the labeling process. So how beneficial do you think Flyte's signaling or human in the loop feature can be in your case? Just wanted to bring it up because we demoed it earlier.
So it's true and not true at the same time. So basically, like, so the way that we set up active learning is like, so look, again, I don't want people to confuse human in the loop and active learning, right? I mean, so technically you can have a setup where active learning is you use this programmatic approach to select the data, and then you route this to an auto-labeling model like a YOLO V8 that's going to generate the annotations and it comes back, right? Of course, like if you're going to use human intervention, this is the place where you want to do that because you can either validate the annotations that come back or you can add your own like take on like, man, I don't trust the curation logic in there or whatnot, right? I mean, so basically like, so So definitely, like basically, like the fact, like Flyte has more flexibility for basically like even workflow interruptions, right? I mean, basically like and pausing and whatnot, because like again, going back to Flyte, I cannot tell you the number of times where you have a process waiting for the annotations to come back. They come back like maybe 2 hours later. By then, like basically like the workflow has expired, right? I mean, so basically like this is a very important feature over here, right? I mean, so, and I think that's like Flyte is the only like a workflow that like I know is not going to have that problem, or not that obviously, right? Yeah, I mean, so basically like so. But I mean, I would say Flyte gives options, right? I mean, to use like because like the same problem applies though, because we're talking about human intervention as being like basically you need to pause the process and basically have something else coming in. So basically like almost like the real value is like connecting two different workflows, which can be each asynchronous, right? I mean, so basically like and you would have exactly the same problem if you used an external auto-labeling like model anyways, right? I mean, and so basically like yes, Flyte does offer a lot of flexibility in that sense.
Also key to point out that signaling, the thing that sends the signal back to the Flyte workflow can also be a Flyte workflow.
Exactly.
So important thing to note.
Awesome. Thanks again, Jennifer, for joining the call and sharing your journey with us today. Love the discussion. Would love to have these kind of discussions at every OSS Sync.